Let's put hands together and do better.
I think it's working. It's just like say the light was off.
Okay, hello everyone. Yeah, so happy to be here. I believe this is my second time in Lagos in about 14 years. Yeah, happy to be here. So my name is Favour, but you guys can call me Favour. Right, I guess that's the Nigerian way of saying it. So today we're going to be talking about building an AI documentation agent for your API using RAG. Can I see by hand anyone who has ever heard of RAG before? Okay. Okay, a handful of people. That's not bad. Also, please excuse my Ghanaian accent. Ever since I landed, I noticed a lot of people find it a bit difficult to hear me. As I said earlier, my name is Favour. I currently work as a developer relations engineer at Swing Finance. So if you haven't heard about Swing Finance before, we're a digital asset liquidity aggregator that helps Web3 teams access billions in liquidity, right? So we facilitate swaps between blockchains. Right, so let's get into it. So who am I? So I have 7 years on hand experience as a software developer. I've worked mostly in finance. I spent about 4 years as a fintech engineer, building financial solutions for tons of users. I'm also a blockchain developer with over 3 years in the Web3 space. I'm a technical writer, having worked at several organizations. I'm also a content creator with over 60,000 followers across my socials. I'm guessing some of you might have seen me on Twitter. If you haven't, it's fine. I'm also a founder. I run a small tech pharmaceutical startup in Ghana. That's something I haven't actually announced on my socials, but I guess you all here are the first to hear about it. So that is that. I've also onboarded thousands into tech via content. So if you know me from Twitter, you know I do a lot of Twitter spaces. I write a lot on Twitter. I write threads. I'm always loud on Twitter. Yeah. I also dream of becoming a pilot one day, but for now I'm a drone pilot. Yes. Who would like to go on the first flight with me? I promise the going will be smooth, but they're coming back. Okay, so I guess the first title sort of describes why we're actually talking about this, right? Which is developers spend 35% of their time understanding just how to use APIs. How many of you have ever gone on an API documentation and then you're not exactly sure where to even start from? Can I see by hand? Right, okay, I think a lot of us. Yeah, so just to add to that, a few years back when I was working at my first job at Texo Ega now, what happened was that we actually got our license to become a PSP, that's a payment provider, and we had to integrate a slew of APIs just to be able to move funds from, say, one telco to another telco, one telco to a bank. So to process bank transactions and mobile money transactions. So once we finally got our license, there was this one company that had all the APIs in one. And we were really excited about integrating their solution. But as far as I know, even till now, this was like 4 years ago, they hadn't still integrated them. And they actually missed out on a big opportunity because none of us working at Texas at the time knew how to integrate their APIs, even though they had everything straightened out in their documentation, because their documentation was just too difficult to follow. And part of that was because it was written a really long time ago. A lot of it was outdated. And the worst part, well, I wouldn't say the worst part, this was in PHP, and we were building in C#. no hits towards PHP developers. But when the documentation was actually written out, all the examples were written out in PHP, it made it quite hard for others who were, say, integrating with C#. It made it harder for guys like us to actually integrate it, right? So we actually tried reaching out to their team, and they actually set up a group chat for all of us to, communicate, talk about our problems, and see how, we could actually get past integrating their APIs. So what happened was that the guys who they had in that group, they weren't actually developers. It was their support team, and they weren't exactly technical. And they would go on and on, giving us generic answers to every question that we asked. And because of that, we just decided to go with someone else, and they lost probably millions in transaction volume just because of that. Because that particular company right now, Texel Ega now, they are processing like hundreds of thousands of dollars in transaction volume every month, right? So they actually missed out on good business because we couldn't really understand how to integrate their API, right? So that's from what the research is saying, which is that developers spend 35% of their time just understanding how to use APIs, right? So why does traditional API don't fall short, right? Static documentation gets outdated quickly, right? That's one of the points. I think I made that point once I was even telling you about the story. What I had to go through whilst I was integrating that particular company's API, which is that parts of the API gets updated, but the documentation is not updated immediately, right? Or probably there could be a page where they keep all the updates, but it's hard to find it, right? The second is that developers struggle to find relevant examples, right? So one example could be you are using Ruby on Rails. You are trying to integrate a particular API. The API is in PHP, and you don't really find an example around Ruby on Rails, right? Context switching between docs code and implementation. You have to go read a lot of docs, then you go find where the code example is, and then you have to find out how to actually implement it. It takes quite some time. So whilst you are there trying to navigate the documentation, you sort of get lost in where you are. No understanding of developer intent or use cases. You might see a random example out there on the documentation. You're not exactly sure what to use it for. Probably they might put out examples there that just show. Say, let's take Paystack for instance. They might put out examples out there that just shows you how to probably just make a simple transaction, right? Transfer funds from one bank to another bank. But you're actually building a casino, and there's going to be a lot of microtransactions. So there's no actual example that relates to what your particular use case is. One size fits all approach doesn't match various skill levels, right? And that was the thing. When I was actually integrating that API, I was just a junior, right? And that was my first job. And those guys made me almost quit because we had very numbers of calls. My CEO talking to their CEO trying to get this thing to work, but they couldn't actually find time to allocate their resources towards us. And I was just stuck, just going through all the examples they had, and I didn't actually know what to make of it, right? So think about it. What if your API could talk? Like, what if you could actually, what if a user could go on your API documentation, they're trying to integrate your API, and then they could actually talk to it, and then it would actually give them answers, straight to the point answers on how to integrate your APIs, right? So imagine this dev experience, you're a developer, you ask a question to the documentation, how do I authenticate and get user data? And the API agent actually responds to you, here's how first to do it, get your token, blah, 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 whatever, you get it? Right, so enter RAG, Retrieval-augmented generation. And so what is RAG? RAG stands for retrieval, find relevant information from your knowledge base. Augmented, enhance AI responses with retrieve context. And generation, create natural contextual responses, right? So I'm just going to explain, I'm going to put it in plain English to you what it does. So AI models I'm sure we all know what an LLM is, an AI model. Anybody, please show by hand. Okay, at least I'm sure most of us have. We've heard about ChatGPT models. We have GPT-4, GPT-3. We have, I think Cloud has open models and stuff. So what happens is that, let's take GPT-3 when it first came out. GPT-3 was trained with data and had a cutoff point, as of 2022, I believe. So what it meant is that if someone prominent died, let me say 2 years later, in 2024, if you were to ask that question to GPT-3, it wouldn't know how to answer that because its cutoff data point was at 2022. So it only understands questions you would ask it all the way to 2022. If someone died in 2024, it wouldn't know that, right? So how do we then keep the model updated? I mean, GPT-3, the fact that it doesn't know that someone died 2 years later doesn't mean it's not powerful enough, right? It's been trained with tons it's been trained on a very large data set, so it can be able to answer basically anything you want it to answer. So how do we keep the AI model updated, right? That's where RAG comes in. So what RAG does is that, what RAG is going to do is that it's going to enable the AI model to be able to, basically like search the internet, go on the internet and then pull the latest information, and then using its current training, what it already knows up to 2022, give you an answer. Right, so that's what RAG is all about. It enables us to pull data from several external sources to help keep the information being generated by our LLM up to date, right? Okay, so how does RAG go against traditional docs? As you know, we're in an AI age. Everything is being innovated with AI. So what it means is that certain things will now become, you can now label them traditional, right? Or traditional. Yeah, you can label them traditional because once it's been impacted by AI, it's never going back. So with traditional docs, you've got static pages, as we all know. You go to page tags documentation, and then all you're doing is just scrolling through it, right? It has generic examples, so meaning if all the examples out there are in PHP, that's all you're ever gonna get. If you come there with, if you come and you're looking for examples on, say, Ruby on Rails, okay. If you come looking for examples on Ruby on Rails and you aren't getting it, then that's all. You're not gonna get any because the developers didn't add that in. So we've got manual updates, meaning that the developers always have to go there and actually put out the updates on the documentation. If they don't do that, then you're not really gonna get. You're not really going to get any updates. Search and scroll. So always you have to be on the documentation. They might have a little search bar up there. You can sort of search for whatever it is you're looking for. And then one-way information. So basically, what you see is what you get. Whatever you see on the documentation, that's all you're going to be reading. No new data is going to be added instantly for you, right? But with RAG-powered agent documentation, what's going to happen is that you have dynamic conversations. It's sort of like chatting with ChatGPT or Claude or any other AI tool out there. Contextual code examples, right? So you see what I said with traditional docs, they have generic examples. With RAG powered agent documentations, what's going to happen is that even if the known examples on the documentation is just PHP, and you're coming there with, say, and TypeScript, the AI agent can actually provide examples for you in whatever programming language you are using, right? So it gives you contextual code samples based on whatever stack you are using, right? Auto-sync with code base, the developer can actually set up a sort of workflow the developer actually set up a workflow that's whenever the documentation gets updated, the agent is also updated. The agent will be able to ingest the documentation pages and then be able to keep itself updated, ask and receive. So just like talking to ChatGPT or talking to Claude or whatever. And then interactive guidance. So if at any point you have a problem or you're stuck at any point, you can actually go back to the agent and ask it, what do? I got this error. How do I solve it? right? So let's move on. So enter Agentic AI, building smarter agents. So Agentic AI refers to AI systems that operate on a high degree of autonomy, making decisions with the use of an AI model and taking actions to achieve specific goals without constant human oversight. So just to put that in, plain English, it's sort of like it's sort of like an AI model that can just make decisions on its own once some predetermined conditions have been met that you have set as a developer, right? So one thing a lot of these agentic AI agents have is that they have access to something called tools, right? And these tools actually help the agents get access to external sources of data, or basically just perform some task. Like you could integrate it into, say, Gmail, for instance. Once it reads your calendar and it finds a meeting, it finds there's a meeting that has been set for you, say like 2 hours, then it could then connect to WhatsApp as a tool, WhatsApp's API as a tool, and then send you a message on WhatsApp that as a reminder that you actually have a meeting upcoming, right? So I'm just going to talk on the agentic tools. Okay, I should probably just touch on it. Okay, so I think, as I said earlier, agentic tools just help. It just helps the function. Okay, agentic tools or functions are features that enable AI models to interact with external systems, as I said earlier. So these tools will just sort of help the AI model be able to access external data elsewhere, or probably connect to a different service where they can perform certain actions. So I don't know if anyone here has used Zapier before. Zapier, has anyone tried it before? Okay, you've tried it, nice. Okay, so if you've used Zapier before, that's sort of like what the tools are, right? So the functions may include gathering, information gathering, browsing the internet to collect data, or connecting to a database to pull information, services integration, connecting to an SMTP server to send emails when trigger is fired, or just information processing, transcribing text from an audio and playing it back using an AI voice. I mean, there's a lot you could do with it, right? But in our context, we are going to be using it for, documentation. Right, so let's look at a real world example, and this is something that I'll actually let us try. I actually built one of this for Swing Finance. Right, so I'm a DevRel. What I do most of the time is documentation. I'm always in contact with the product team, to always document whatever changes or new features that have been added on the platform. And one other thing I do a lot as a DevRel is support, which is that we have Swing has APIs that other teams can integrate into to perform swaps, right? And what happens is that some of these teams, we actually set up like a group chat with them just to keep them updated, where they can ask us questions directly. And at a point, we sort of realized that there's actually a way to do away with that, having to have teams reach out to us, and then we set up a group chat with them and always having them ask us endless questions, right? So once we caught on this idea of RAG, agentic AI, we actually started building something to, quite literally replace me. Yeah, so what we did, so this was a challenge, all right? Swing.xyz offers 3 integration types: widget, API, SDK, with complex crossing functionality. So our APIs they are quite simple, but if you're someone new to Web3, you might struggle a bit to sort of navigate your way around it, right? So some developers do get confused, and they have to reach out to us and all. So the solution in action was a solution in action. The developer would ask something like, how do I integrate token swapping into my React app, right? So what we wanted to do was to build an agent that when a developer asks this question, say on Telegram or something, the agent would respond immediately inside the Telegram chat to the user. Okay, I see you want to integrate swapping. Let me clarify, blah blah blah. Then gives it like a full answer. something that I would be doing. You get it? And in my time, there's some of the teams we work with are in different time zones. So I'm in GMT time zone. A majority of our customers are in, I'm not exactly sure the name of the time zone, but they're Eastern European, right? So they're always awake 4 or 5 hours before me. So when I wake up, I see a lot of questions that they've asked, and I'm not exactly there to answer because I'm still asleep. You get it? So what the solution we were trying to build with RAG is to basically enable me to have some time and also be able to respond to customers as soon as possible, even though no member of the team is available, right? Pydantic AI, right? So Pydantic AI is a Python agent framework designed to make it less painful for you to build AI apps, basically. So, I mean, you can do a lot with it, not only building agents. You can connect it to, it supports major AI models out there, like GPT-3, GPT-4. It has built-in support for tools and function calling. So basically, you don't have to code all those tools yourself. It also has context management, automatically handles conversation history. So it comes built-in with a lot of tools and a lot of features that basically just makes it less painful for you to build AI apps. You can use it for a host of stuff, right? So what are we achieving, right? So this is where I sort of have to get into specifics and get a bit technical. So we are going to build a fast API with Pydantic request response models. We're also going to set up a vector database using Supabase. I mean, with this, just for this example, we're using Supabase, but there are other databases out there that support vector databases, right? So this database is just going to be there as our external source of data to our AI model. So if you remember earlier, I mentioned that because of RAG now, AI models can now connect to external sources of data. So in the context of our documentation, we're actually going to set up our own database where these AI models will be able to fetch data from and then respond to our users, right? And they are going to be there just for content ingestion, right? So we are going to build a basic agent with retrieval tools, querying and reasoning. We are going to create a simple chat interface for testing, and the outcome is that the AI agent will be answering basic questions. So building our AI agents. So we're going to be using Python as our primary programming language, and GPT-4 as our LLM of choice, and Pydantic as our SDK for seamlessly building AI agents. So so the initial stages for building, so this is our initial setup. Okay, this is a bit, just a minute. I'm trying to present something else. So I'm trying to present something else. Okay. How do I?
Okay. Next to that.
Yes.
Yes.
Okay. Okay. Thank you. Okay, so let's look at our Supabase setup. I don't know, it looks blurry to me. Can you guys see it? You guys cannot see it. Oh, okay. Is it better now? Okay, so this is our database setup. So we are using Supabase because Supabase supports vector searches, right? I believe Supabase is actually built with the actual database powering Supabase is PostgreSQL. So meaning if you can also achieve this using Postgres as well. So we are going to have a couple of tables here. We're going to have one called messages. So we're going to be storing every message that our users will be asking the AI model, right? We're also going to be storing site pages. So what's actually going to happen is that we're going to have a crawler, right? A crawler agent that is going to go on our static documentation page and then list out all the pages on our documentation using a sitemap. So in case you don't know, most websites have what is called a sitemap.xml, right? So I think for Swing Finance, it's sitemap.xml. So if you go on any website and then, okay, let me zoom this. Apologies about the internet. Okay, I'll just move on until this is loaded. And this is also loaded. Okay, perfect. All right. So the site pages is just basically the links of all the pages on the website, right? So if the sitemap had loaded, I would have shown you how that looks like. So basically, it's just the name of the page and then the link to the page. So why we need that is because our agent is going to be running automatically. Say it will run once every day or once every, we could program it anyhow we want to program it. Maybe it could run once every 6 hours, once every day, once every 2 days, or runs whenever the documentation is updated, right? So what's going to happen is that once the documentation gets updated, the new page or whatever that gets added to the documentation, that the link and the name of the page is going to get inputted into this table, right? So that the new table, the new page that was added to the documentation will be tracked by our agents, right? So we also have another table called code examples. So basically, what's going to happen is that we are going to comb through our entire documentation and find specifically any code example, right? So whatever code example is found on in our documentation, that's going to be inputted here, and the agent is going to be doing this automatically. So what the agent is going to do is that the agent is going to look through the page and detect that, okay, this is text and this is a code example. It's going to be able to recognize code examples, and then it's going to automatically insert it into the code examples table, right? So we also have code example files. So if there are any files in our documentation, let me say like files that are on GitHub, for instance, we can input them into this table, and the agent will access this table and the GitHub link to that particular code example, and our agent will download it. It will ingest it into its training set data, right, and use that to answer our users. Then we've got training chunks. So these tables are actually just, they are exactly what they are. They are chunks. So what's going to happen is that whilst our crawler is inputting the data here using our model to determine what is a code example and what is just regular text, it's going to break them into chunks. So I wish this had loaded. I would have showed you how it's like, but it looks it's just loading forever. So I will just continue. I'll just move on. And I've lost connection totally. All right. Okay. I hope I'll just continue like this since the internet isn't working. So the first thing we are going to do is that we are going to be ingesting we're going to be ingesting data. So I don't have to explain that word, right? I'm sure we all know what ingesting means. This.
It's the internet.
It's the internet.
Okay, you can something like this.
Yeah, I can actually. Okay, so sorry about that. I'm sure I have to explain what ingesting is, but basically, our agent is going to have to swallow data. It's going to have to eat up all the data we provide to it, right? So first, we'll need a way to allow our agent to ingest data. So basically, to download data. It's visible, right? Okay, so we will need a way for our agent to basically ingest data, right? And we can do that in two ways, one of which I've already explained to you, which is to use the sitemap page for our documentation, right? So every document, so most documentation pages will have a sitemap.xml data for crawlers, right? I think Google uses it to be able to rank websites, right? So I think for SEO reasons, a lot of documentations will have a sitemap.xml page. So in your documentation, once you are done putting together your API documentation page or whatever, you have to make sure you have a sitemap.xml page, right? I mean, you don't need to do that, but in the context of this, you'd have to do that. So in your sitemap XML page, you can define where pages where all the code samples are stored, pages that contains guides for developers to follow, and pages that contain API endpoints definitions. So the other way is to export our entire documentation as The other way is to export our entire documentation as a JSON or YAML file, and then digest the contents of our API docs. So if you're not, so you can use the second method if you aren't going for the regular, documentation pages, like how Paystack has like a developer's page. If your API docs is basically like a Postman documentation and or Swagger doc, right? All you need to do is just to export it as JSON or YAML, right? And that's basically would give you your entire documentation schema. So for the context of for this particular example, we're actually going with the sitemap XML because we are talking about taking an entire developer's documentation page and turning it into a conversational doc where developers can actually talk to it. So this is actually how the sitemaps.xml page looks like, right? Some of you might have accidentally stumbled upon one sometime. So it's actually made with XML, and it just contains the links on that particular site, all in XML. That's just basically what it is. So for our example, we're going to need this because we want our crawler to go into this sitemap.xml and basically pull all the pages it finds in there, right? So it's going to access the link, and then it's going to open the page virtually, and then it's going to read the contents of that page and download it and ingest it. And once it's done ingesting it, it's going to actually, for every page our crawler is going to look into, it's going to ask itself, okay, what am I looking at? Is this text or is this a coding example? Because we're using an AI model, we can be able to, the AI model can actually be the brains and just determine that. And once it determines it, it's going to know where it's going to put it. Is it whether it's going to put it in training chunks or whether it's going to put it in coding example chunks, right? So moving on, does this work? Okay, good. So one thing we are gonna do is that once our crawler has downloaded all the data on the content page. 4 minutes. So what we're going to do is that once our crawler has downloaded the contents of all the pages, right? The next thing we have to do is we have to tokenize it. We have to tokenize the contents that we've gotten. And Tokenizing basically just means turning the content into an embeddable, turning it into vectors, right? So tokenizing our content creates vector embeddings that makes it easier and faster to query. If you were to go on, say like using a search bar or something, or probably you're on SQL, if whenever you are trying to filter text, usually what will happen is that you filter based on similarity, right? But what that would mean is that you wouldn't be able to query exactly what you are looking for. We are trying so the problem is that traditional search uses exact keyword matching, right? If a developer asks, how do I authenticate users? If a developer asks, how do I authenticate users? The documentation says, user login implementation. Okay, so then it tells you, no match, even though they are the same concept, you get it. But with embeddings, what happens is that it converts the text into numerical vectors, and these vectors are just an array of numbers, right? And similar concepts get similar vector representation. So authenticate and login end up being close to each other in a vector space. So that makes them, so basically they become semantically linked. If a user is searching for users, for instance, the response it could get would be, it would find whatever it is related to users and also accounts, because users and accounts are semantically linked together. Right. So, so the first step is that we have to set up our agents, right? So, let me actually get into that. So, I actually wanted to take us through. So I think I actually wanted to make time to take us through this, but I believe time is not really going to permit. So I'm just going to rush us through how it looks like, right? So basically, in the code, we're just basically bringing all of this together. We're bringing together Supabase. We're bringing together our Supabase database. We are using OpenAI, right? We're using GPT-4, and we're actually setting up a prompt. We're actually setting up quite a very huge prompt, right? So using Pydantic's agent, Pydantic's agent actually lets us create a class where we can actually inject our database, inject stuff like our database and the model that we're using into our agent. So I mentioned earlier that we had something called tools. So just for the sake of time, I'll just rush us through this and then we can take questions. So I mentioned that we had something called tools. So what Pydantic does for us is that it lets us create tools that basically operate operate autonomously. So the moment I define this as a tool, what's going to happen is that the agent is actually going to use this text I've put in the comments to actually know what to do. So I don't even have to call it automatically. Whilst the agent is trying to answer the user, it's going to look at the list of tools it has at its disposal. Over here we have like 3. I've actually put together like 3 tools. One to fetch all the relevant, retrieve relevant documentation, list all content, and get content by URL. So it's not exactly going to use all these 3. It's going to use it if it feels like it needs it. So it's going to be reasoning behind the scene. If the user asks a question, it's going to go through all the tools and then just ask itself, what exactly do I need to answer this user? So if it says that, if it determines that it needs this particular tool, it's going to read a prompt inside. So if this particular prompt is telling you that it retrieves all relevant documentation, code examples, training content based on the query with RAG, right? So what's going to happen is that it's going to get the embedding. So it's going to take the text the user has passed to it, and it's going to check against it's going to create an embedding out of it, basically turn it into vector. And based on that, using Superbase, we're going to be able to query the database to see what text or what page or what code example is close to what the user is asking for. And then based on that, it's going to pipe that response. What the agent is going to do is that the agent is then going to take that response, the pages that it found, and then it's going to pass it through the model. So it takes that as context, and then it passes it through the model. Say in our case, we are using GPT-4. It's going to pass it through GPT-4, and then actually generate a contextual response to our users. So I'll probably have this out on Git for anybody who wants to look at it. But at this point, because timing does not permit, I'll have to go to taking questions. So, any questions for me? No questions? Okay. All right, so thank you, everybody.